We've all been waiting for someone to unravel the mysteries of the universe, and the James Webb Telescope has been created to do exactly that. All that the James Webb Space Telescope took was 25 years to develop, 17 years to build, 8 launch setbacks, and 5 months of alignments, but it is almost available at launch. New photographs from the European Space Agency or ESA and a video from NASA reveal views of stars captured by a wholly aligned space telescope, complete with sensors. NASA ESA took 7 galaxy images through the James Webb Space Telescope. Webb's 3 imaging instruments and its spectrograph and guiding detector are represented in the 7 pictures taken. The photos depict a field of stars in the Large Magellanic Cloud and the galaxy roughly 158,000 light-years distant from the Milky Way. It would be the most prominent satellite galaxy if it orbited our galaxy. Instead, however, it may be only passing through or merging with our universe. The following instruments were utilized to obtain the LMC picture. NIRCam, or near-infrared camera, is Webb's principal eyes of seeing infrared ranges beyond what our eyes can already see. It also has a coronagraph, which can filter off light from stars so that planets may be found directly. The next is MIRI, or mid-infrared instrument. MIRI can detect objects in wavelengths well beyond those seen by NIRCam, allowing it to discover fainter sacred objects such as faraway galaxies or comets on the fringes of our solar system. MIRI has to be chilled to a few degrees above zero to perform these observations. Otherwise, the heat from the equipment would damage its sensitivity. The next one is NIRIS, or Near-Infrared Imager and Slitless Spectrograph. It is an imaging system that works in unison with the fine guidance sensors to disintegrate and identify the composition of viewed objects. It will deal with things including exoplanet atmospheres, which might tell if certain Earth-sized worlds are Earth-like, a bit more poisonous like Venus, or nearly airless such as Mercury, or something entirely different. FGS, or Fine Guidance Sensor, is another one. The Fine Guidance Sensor does what it says. It assists Webb in precisely pointing out objects. NIRIS and FGS function together as a single instrument, with NIRIS serving as the primary eyes despite FGS's poor imaging capabilities. The final one is NIRSpec, or Near-Infrared Spectrograph. While there is an imager for navigation, this is primarily a piece of scientific equipment that breaks down light into precise wavelengths. It will aid Webb scientists in their quest to understand what happened in the early cosmos when there were a few very heavy metals. NASA also published a video commemorating the final alignment and the image shared by the ESA. Finally, after years of planning and research, the James Webb Space Telescope, or JWST, was launched on Christmas Day 2021. The European Space Agency, or ESA, NASA, and the Canadian Space Agency collaborated to create the telescope. The telescope has been named after a past NASA administrator, James Webb. Webb's participation in removing LGBT persons from the administration during the Lavender Scare, a lesser-known counterpart to the Red Scare of the 1950s, has sparked criticism. Webb was working at the State Department at the time. NASA and its collaborators will commence commissioning many research instruments now that the imaging equipment is correctly oriented. These are elements within imaging tools that may filter various types of light, alter cameras for specific configurations, or apply specialized lenses. It might take many months, as could some calibrations, to ensure that the telescope remains temperature stable as it travels between targets. Mission Control will keep an eye on the mirror alignment throughout this period to ensure it stays in position. The optical calibration of NASA's $10 billion James Webb Space Telescope is now complete, representing another crucial step toward a fully operational infrared instrument. In addition, the observatory's onboard research equipment, mid-infrared instrument, near-infrared camera, the near-infrared spectrograph, and near-infrared imager and slitless spectrograph can now capture sharp, well-focused pictures. JWST focused on a section of the Large Magellanic Cloud, a tiny satellite galaxy of the Milky Way that offered a dense field of hundreds or even thousands of stars for optics testing. Photographs from 4 instruments are included in the release, and images from the Fine Guidance Sensor are used to follow guide stars and properly aim the observatory. The image from MIRI sticks out in the first set. If you look closely, you can detect emissions from the interstellar medium and starlight. Calibration photos from the observatory's Fine Guidance Sensor have also been made public. However, it isn't there to undertake scientific imaging because it utilizes 2 sensors to orient the observatory properly. At NASA's Goddard Space Flight Center, Lee Feinberg was the Webb Optical Telescope Element Supervisor. Those spectacular test photos from a correctly aligned telescope, he said, show what individuals from all across the world can do when they have a strong scientific ambition to explore the cosmos. Ball Aerospace's Webb waveform sensing and control scientist was Scott Acton. He claims that those visuals have fundamentally altered our perceptions of the cosmos. There are galaxies around, a symphony of creation encircles us. He desires that they will be visible to everyone on the planet, in addition to the current 7 photos. Webb's initial 10-year project will examine the solar system, observe exoplanets firsthand, image the first galaxies, and investigate the mysteries of the universe's beginnings. The next giant observatory is honing its eyes and is well on its way to solving the universe's riddles. The James Webb Space Telescope, introduced in December of 2021, arrived at its position roughly 1 million miles or 1.5 million kilometers away from Earth in January 2022, and has also been hard at work preparing to perform science. On March 11th, the spaceship completed fine phasing, an essential step in its preparations, the agency stated on Wednesday, March 16th. The telescope has also satisfied all the required optical parameters and reliably sends light to its instruments. As a result of this accomplishment, NASA is optimistic that the observatory will meet its science goals. According to the report, the new picture is centered around a star. The observatory's further objective is that the commissioning procedure previously focused on a star in Ursa Major's constellations around 241 light-years away from Earth. Other stars and constellations that the agency did not identify may also be seen in the background. The enormous mirror of the JWST, which spans 21 feet or 6.5 meters, contributes to the telescope's observation capability. However, because such a large mirror cannot be launched entirely, the observatory's designers divided the golden surface into 18 independently adjustable hexagonal portions. Mission engineers have fine-tuned the arrangement of those parts for weeks to bring the cosmos into focus for the giant telescope. NASA stressed that the procedure isn't over yet, but the crew has completed the most challenging and nerve-wracking tasks. The agency also shared a selfie image taken with a lens designed to photograph the reflective surface to aid engineers during alignment. According to NASA, the team's other key preparation stage is calibrating the equipment aboard the observatory, which should be completed by early May. This work will be finished this summer, allowing JWST to begin scientific observations. Understanding the universe's origins, determining the habitability of exoplanets, and choosing the influence of unexplained dark matter on the cosmos are all on the observatory's research agenda. The Webb Group picked out more than 20 years ago to create the most powerful telescope anybody has ever put in orbit. They then came up with an innovative optical design to achieve challenging research goals, according to Thomas Zurbuchen, a deputy admin for NASA's Science Mission Directorate. Today, we can confidently assert that this strategy has delivered the 7 shocking images of the galaxy. With that, we have come to an end of this video. If you enjoyed it, then make sure to like this video and share it with others. Don't forget to subscribe to our channel and press the bell icon so that you never miss our videos. See you next time.